What's going on, guys? We're to example 2b of 6.6. I've done a little work in terms of sketching a little graph for you guys. As you can see, we have a real component of -3 and a imaginary component of -4. That's in quadrant 3 right now. Simply, I want to find that radius, that hypotenuse, that magnitude, that distance from the pole, or actually, I failed to use another word, modulus. The modulus of a complex number, of modulus of a vector, the absolute value of a vector, absolute value of a complex number. It's all the same thing. It's the radius, it's the hypotenuse. So Pythagorean theorem, and we get a radius of 5 in the quadrant 3 direction. Now, something I'll explicitly state here again is that we are trying to figure out an angle from 0 to 2 pi. And so again, we have a opposite of -4 and an adjacent of -3. So that makes me think of tangent. So let's go ahead. We would need, all right, the tangent inverse of 4/3. Remember, because -4 over -3 would just be positive 4/3. You put that in your calculator, which I did before, and you get 0.9273 approximately. Right there. All right. So 0.9273. Now 0.9273, if you think about it, well, from here to here, that's 3.14. That's pi radians, right? So 0.9273 is in quadrant 1. Remember, tangent is positive in quadrant 1, but it's also positive in quadrant 3. So we don't want the quadrant 1 value. We want the quadrant 3. Now, tangent's range is limited, right, to, I believe, 1 and 4. From our inverse tangent section, we learned that. But we can easily figure this out because if you think about it, 0.9273 is over here. Well, if you just add this much to it, you'd be over there. That's just adding pi. So what we really want is this. Okay, so we're going to need to take 0.9273 and add pi to that. And so if we do that, let's go to our calculator again. Plus pi, get 4.06. We'll write that down. So the actual angle that we want. So the textbook does this. I'm gonna say that's theta prime. Make that blue so it matches. Nope, still not blue. But the actual theta we want would be 0.9273 plus pi, so that we're pointing quadrant 3. And that means this is, actually, always do approximates. That's 4.0689. And so if you want to write this in polar form, you'd want to write the radius first, which is 5. The real component is the horizontal component, which is represented by cosine of 4.0689 plus I, which is the imaginary component, sine of 4.0689. And if you were to put this into your calculator, 5 times that, you will get -3. If you were to take 5 and multiply it with sine of that radian measure, you'll get -4. And so again, that's why this is the polar form. And that's your answer.